49. We have tested over this already. Do not tell me you don't know how to do this, or I will make a really nasty mastery factoring quiz like they do in Algebra 2. Don't tell me you can't do this. Okay, any questions so far? Now, what are the factors of 40 to add to give me 14?
4 and 10. -4,
I think that's what I heard. Does everyone agree? 4 and 10 multiply to give you 40. They -4 and -10 add to give you -14. Very good. The next one is the hardest of the factoring cases. Y'all remember it being the one that was tough in the beginning. But these, you flew through these, right? That one's tough. Why is it tough? It R equals 0, so that's actually helpful. What makes it harder than the last? There's a number in front of the x squared. Does everyone remember we hated those, right? What did we have to do when there was a number in front of the x squared?
Just like 8 to 25.
If it went into all three, you could, but it doesn't.
Yeah.
So how do we set this up? Yeah, unfoil, right? You kind of think of what the factors of 25 are and what factors of 3 are. If you do not have an example of this on your note card, on your factoring note card, put this one on there. You really need an example of this so that you can look back at that note card and remind yourself how to factor one of these hard ones. So what I'm going to do is I'm going to do 1 into 25. What else goes into 25?
5.
And then 1 and 3. 1 of the 2 lists I'm going to write both ways. So 3 and 1, 1 and 3. I'm going to multiply the inner terms together. I'm going to multiply the outer terms together. And I'm going to see which ones add to give me -20. 20 first of all. 25 and 3, does that add to give me 20?
No.
75 and 1. No. 15 and 5. Yes.
That's to be different.
So I multiply the inside ones together, 15, and the outside ones together in 5. And see which ones add to give me 20. And so I get.
Doesn't 5 times 5, it just 1 times 3.
No,
No.
you do. No, that's 5.
Yeah, I feel like 5 times
It's 25.
Right.
You always do inner and outer.
So like
Oh,
5
I
times.
yeah. Yeah. So if I use the top one, yes. Yes. Did everyone hear Bailey's question? She said, what if I use the 1 and the 3? Would that have also worked? It would have, because 5 and 5 is the same either way. So that's fine either way. The 5 came from the 25x squared, right? So it has to go in the front. So it's 5x and 5x. The 3 and the 1 came from the 3. Normally, keep these in the order you circled them in. This is a special problem where it wouldn't matter because, like we just said, 5 and 5, it doesn't really matter. Both minus, remember if this is a plus, these have the same sign. And because that's -20, -15 plus -5 is -20. Set each piece equals to 0. This is also a little bit difficult. In the last one, how many of you just did the last one in your head? You're like, it's 4 and 10. Okay? Are we probably going to do this one in our head?
No.
Probably not. Some of you might can get away with it and do it correctly, but most of you will need to go ahead and write 5x minus 3 equals 0 and 5x minus 1 equals 0. And solve those two linear equations. Add the 3 over and divide by 5. Add the 1 over and divide by 5. This was a very difficult problem. Are they all this hard? No. So this is one of the hardest of the solve by factoring. If you remember solve by factoring, when we first learned that a month ago, this was the bad one. And what do I have to do on the next one? Not yet. You could, but. Step one, anytime I'm solving by factoring. Get 0 on one side. Every single time, get 0 on one side. What factoring technique do I always try first? Before that. Who said the word?
I mean,
Look at your note card. Let's break it up. Look.
I can say it out loud.
Use those note cards.
Oh,
Take creative comments.
Yeah,
I was doing it
how?
Creative comments factors. Everyone agree? That's enough, isn't it? To be done? 7 times greatest common factor is all you need. A 3 and an x factors out of both. Set each piece equal to 0, so 3x equals 0 and x minus 6 equals 0. So x equals 0. Any questions though? Okay, solve by taking square roots. It's also been a while since we did this. Step 1. What would I do on this first problem? Square root both sides. Anytime you take a square root, what do you do? Plus or minus. Some of you who came in later, I had some of you that have been in this class all year. This is a lot of the stuff you missed. We walked through this a lot slower in August. So, if this does not look familiar to you and you need to come sit with me and go a little slower, let me know. We can definitely do that sometime. Any questions so far? Yes. What's the last thing I should do? Okay, good. It wouldn't be bad on your brain to separate this into 2 different pieces. You don't have to do that, but it's definitely to help our brains out a little bit. Separate that into x minus 3 equals 3 and x minus 3 equals negative 3. Add the 3 over. Any questions so far? Is that good? Just like a good little review of some things we've done in a while. Okay, what about the next one? What am I going to do on the next one? Add 3. Divided by 3. We're undoing, right? Trying to get that x plus 2 first by itself. Square root both sides. Any questions so far? Square root of 12, I'm going to try to break that down. Does it break down?
Oh.
You could do that. I could take it, it's 12 is 4 times 3, right? Or 2 times 2 times 3. Now remember doing the factor tree? So side note. So I can take that 2 out of there. 3 is left inside. Now last time I did split this up into 2 pieces because I was going to try to simplify it. Am I going to be able to add or subtract 2 to 2 radical 3. They're not like terms. So on this one, I'm just going to leave it as negative 2 plus or minus 2 squared square root. I'll leave it in that unsimplified format, or reduced radical format. Any questions about that? Alright. So, this first section in this chapter, the next chapter, is solving quadratics. They do all of this in one chapter because they assume you can already factor and they assume you can already solve by taking square roots. So the thing that they're really teaching you in this chapter is the quadratic formula. So good thing is we can make those assumptions because we learned them already this year. So that's why we did. If you're wondering why I made up a chapter P, you now know. Because the book just assumes we know some things that we may or may not have ever learned. We have now learned how to factor and how to do solving by taking square roots. So today we're going to pick up the quadratic formula. Factoring is going to be the easiest most of the time. Now you saw number 2, that was a tough one, a tough factoring problem. You might could argue that might be easier with the quadratic formula because it was so tough by factoring. But if it's an easy factoring problem, that'll be the easiest option. The only time I would use taking square roots is when it's already set up to do it that way. You know what I mean by that? Those last 2 problems were just set up to where you can take square roots pretty easy, and so we'll do that if it's just set up that way. The quadratic formula is nice because it always works. No matter what the quadratic equation is, the quadratic formula will always give you an answer. So that's what we're going to look at today is quadratic formula answers. This is the quadratic formula. How many of you do it already? Did you know a song? No?
What?
We're going to sing it. We are. We are definitely going to sing it.
You can.
It's like pop goes the
You'll sing it with me. I will sing it first, so I will embarrass myself, and then you can join me in the embarrassment. Why you want to sing it is because if you get this song stuck in your head 1 or 2 times, you will memorize the quadratic formula and you will know it forever. And that's kind of the goal of a song, is that you know it forever. So we ready? Try to sing it with me if you know it. If not, I'll sing it for you, but the second time you have to sing it with me. So it's x equals negative b plus or minus a square root b squared minus 4ac all over 2a. Okay? If you don't know the words, it's okay because they're on the board. Are you ready? Oh yeah, she does it a little different. You can do it that way. I like that too. If you know the quadratic formula, I don't care how you do it. Okay, we ready? Y'all sing with me? I'm watching. If I don't see anyone's lips moving, we will do this until everyone's lips are moving. So if we want to hear this song a million times, that's how you make it happen. Ready? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Y'all are much better than us. Yeah, how's it go?
I don't know. It's like after.
She just doesn't put the X in front of it.
Okay, so instead of x equals, she has top of the answer.
Yeah, she needs to put the top.
If you have a quadratic equation in this format, which is kind of nice, you'll notice it's the same format as if you were going to try to factor it, right? We have to have 0 on one side no matter what. If you have a quadratic in that format, ax squared plus bx plus c equals 0, then we can use the quadratic formula and it will give us the answers. You know how on the first one up here by factoring we got 4 and 10. It would give you the 4 and the 10. It would give you the 3/5 and the 1/5. It would give you the 0 and the 6. It would give you any of these answers we got in this method. But the thing is it can do things that factoring can't. Have you ever come to a problem that doesn't factor? Yeah. Well, then we could solve it before then. Now we can use the quadratic formula. So, what am I going to have to do get 2x plus 2x squared plus 3 equals 0. Oh, sorry. I don't have the next 3 questions. I don't know why. What should I be adding? Thank you. Gives me 2. Maybe that's what I did. Any questions so far? Rearrange it. This format is not quite right. What's not quite right about it? The x squared needs to be in front. If you were solving by factoring, wouldn't you do the same thing? Now we could try this by factoring. It does have greatest common factor, but then you would end up noticing it doesn't go anywhere after that, so this doesn't end up factoring nicely for us. So, I'm going to do the quadratic formula. And what is the quadratic formula? X equals negative b, right? Well, remember this thing is a, this thing is b, and this thing is c. So we have negative 2, negative b, plus or minus the square root of b squared. Like things find out, you are using a calculator to help you simplify the quadratic formula. Make sure you put the parentheses right here. Now this problem it wouldn't matter, but if there's a negative 2 there and you don't put it in parentheses, it'll say negative 2 squared equals negative 4, which we know is not true, because you square a negative number, we should get positive. So be careful with, go ahead and just put them to be safe. Minus 4 times a times c all over 2. We are going to write this in simplified radical format. We have done that before, right? Have y'all seen something like this before?
Yes.
You didn't know why I was making you simplify it at the time. Probably. Some of you probably did. From algebra 2. So you can type this piece under the square root all in your calculator if you want, or you can do it using order of operations. That's up to you. 4, what's that? 8 comes to 16. Negative 12, is that what you get under that radical? Which is strange, and we have never dealt with that before, have we? Not in this class. Normally, if we have a negative under a square root, what do we do? We can't do it, right? We can't do that. But, does anyone remember from algebra 2 what you called a negative under a square root? I heard someone say it. An imaginary number. It's not a real number. It's one that we know it is I. So anytime there's an I under a square root, when we simplify the square root, 2 radical 3, everyone remember doing this part? So this is negative 2 plus or minus 2i radical 3. Anytime there is a negative under a square root, to fix that, you pull an I out. So if there's a negative under a square root, it makes an I. Then you look at all 3 pieces that are left and see if you can divide anything out of all 3 pieces. Can we divide anything out of all 3? 2. That's 2. So I get negative 1. Plus or minus I squared to the 3 over 2. There is no other simplification I can do for that. I could break it into 2 pieces, but I can't simplify it anymore. So that is our first quadratic formula problem. How was it? Okay, so on the 12, I pulled the 2 out because it has a square root times 2. The square of that's 2. And left the 3 under. negative up here. Okay. Couple of things that are nice to know about the quadratic formula. The piece under the square root, the b squared minus 4ac, isn't that the part under the square root? Can tell you a lot about the type of solutions you're going to get. If the part under the square root is negative, aren't you going to get imaginary answers? That's because you have a negative in your square root. If the part under the square root is positive, you're going to get real answers. If the part under the square root is 0, that's a special case where you're only going to get one answer. So the discriminant can tell you how many solutions there are and if they are real or imaginary. ACT asks this question a lot. Sometimes they make you figure out which one would make it real or imaginary. They'd say, what B would you have to make two real solutions? Have y'all ever seen that question before? And it looks like a really hard question. But it's not if you know the discriminant piece. So this is a common ACT question type. Do you feel like you are knowing a lot more things on the ACT this time? Good. You seniors, December will be a really good one to take because you'll have 2 more months. So you can learn a lot here in 2 months. There's not one in November. For you seniors, December is the last one for a lot of scholarship acts. So December is a big one for you. For you juniors, I would take one at the end of when we finish all the curriculum in this class. I would take another one. Who are my juniors? All you will do after seniors leave is ACT. Wouldn't that be nice?
No.
Getting free ACT help.
The correct answer is that's good. Correct answer.
Good. Okay. I only have one junior in. One of my calculus classes I have a junior in it. And then my other, I'll have to take out my too, so I'll have several classes. No, I mean, she moved here. So she went to a school that had 7th grade out for 1. There are a lot of schools that do that.
We could do that.
We do have 8.
We do.
We have a bonus.
But we accepted. Like you did.
Oh, it is paper.
Yes. My dad is weird.
Oh, yeah.
Okay. This does not ask me to do the quadratic formula. You will waste a whole lot. I hope you started this in your notes. You will waste a whole lot of time on your homework if you do the quadratic formula when it asks this question. It just says to tell how many solutions and whether they're real or imaginary. Do I have to do the whole quadratic formula to figure that out?
No.
No, that's the only part I need to do to figure that out. The discriminant, the b squared minus 4ac. That is the part under the square root that will tell me everything I need to know as far as how many solutions and what times. Is this already set up in quadratic format? Looks good. So what is B?
3.
Negative 3 squared minus 4 times A times C. Right? 9 plus 16 is what you would get if you did that in your calculator. So you get 25 under the square root. Is that greater than 0? It is. So what does that mean? Two real solutions. So that's my answer. That's all I have to do. Again, ACT will ask you those questions. If you do the whole quadratic formula, you are wasting lots of valuable ACT time. Okay, let's look at the next one. What am I going to do? Which part? Two squared. Minus 4 times 1 times 3. Does everyone see where I'm getting that? The b squared minus 4ac. Remember the number beside the x is a, b, and c. Four minus 12 is negative 8. Right? What's that mean? Negative under a radical. 2 and a half. Probably 0, right? You know from what I told you, but so in the quadratic formula, if I were to play this out, I don't want to, but if I were to, I would get negative 2 plus or minus the square root of negative over 2, and there are 2 answers there because of the plus or minus. So when we're doing it like this, I could just Now you can think about it though. I mean, if you're going to get a negative under a radical, you're going to get 2 answers from the plus or minus. And they're going to be imaginary because you have a negative under the radical. This one actually is one that would be really easy to factor. If I were solving it, I would do it by factoring x minus 1 and x minus 1. So when you agree the only answer that's 1, let's see if that works out with the discriminant. See if that gives us what we expect. B squared minus 4 times A times C. Make sure you put that negative 2 in parentheses. I end up getting 4 times 4, which is 0. Which means what? There is one real solution. And you may ask, why is there only one real solution? So back up, don't really do this, it's way too much work. But if I were to go through, and do the quadratic formula, I would get 2 plus or minus the square root of 0 over 2. Well, what's the square root of 0? 0. What happens when I add 0 to 2 and subtract 0 from 2? I still get 2. I don't get 2 answers. Does everyone see why I don't get 2 answers? Any other time I'm going to get 2 answers. The only time I don't get 2 answers is when the discriminant is 0. So that's how we can work with the discriminant. Okay, now I have some more just solving using the quadratic formula to practice some solving using the quadratic formula. So I want you to try. Do it first. Okay, the first one, get 0 on one side, right?
Right.
Have you would be negative, so everything else will turn out the same. So I get x equals negative b. I have a habit of always going to the side that makes the leading function positive, but that's not because of the quadratic formula that uses a factor. If I were going to want to try factoring, I would want that to be constant. So you'll see that I always do that just out of habit. 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 7 all over 2 times 2. Did everyone get that? Any questions about that? Anyone get anything different at this step? Besides Elizabeth, you have some signs different at this point, but they will all come out the same. Okay, so I get 3 plus or minus the square root. 9 minus 56 is a yeah, 9 minus 56, which is negative 47. Alright? Any questions so far? Is 47 reduced? No, but I can take the negative out. The only thing I will do is I will move that negative out in front. And what will I call it when I move it out? I. The 3 and the 4 do not reduce. So we'll stop there. If you did it the other way, your 3 and 4 would be negative. Both 3 and 4 negative. Is that what you got, Elizabeth? Okay. If you did it the other way, the 3 and 4 would be negative, which is completely equivalent because a negative divided by a negative is a positive. So you're fine if you did that. You will be perfectly correct. Any questions about that one? You know how when you pull out something from a square root, when you pull a negative out, it becomes a next. I'm getting a little faster. Are we okay with that? On doing these? X equals negative b. What is b if there's nothing beside the x? 1. And remember the part under the radical, you can type that all in the calculator. To get that value, your calculator will follow the order of operations correctly, so it'll take care of that part. Just don't type the radical in because you want to be able to simplify the radical. The 15 times 4 61, is that what that is? 61. 61 doesn't simplify either, does it? So this is two real answers, but they would be decimal values if you were to find them in the calculator. Because nothing simplifies, I'm going to leave it there. 61 does not simplify. Everyone agree? Nothing goes into 61 that's going to make that radical reduce. I will tell you, if I had my option, I would not use the quadratic formula on this next problem. I'm going to, because this is quadratic formula day. Why would I not use it? Factors of 4 that add a u5 to 4 and 1, x equals negative 4, x equals negative 1. Done. Or plus, yeah, negative 4, negative 1. So I would be done so fast with that. Right? But I just want to show you that quadratic formula will give you the answer even if it's an easy factoring problem. It takes you a little longer. So x equals negative 8 plus or minus the square root of b squared minus 4 times a times b. All over 2a. 25 minus 16 is 9. Can I minus 3? Let's do it. So the reason I stop on those other ones is because I can't keep going, right? I can't add a whole number and a radical together. But on this I can, so don't ever stop there. I will come off if you do. I am going to take James's advice from earlier and say, okay, let's go ahead and separate this out just for my brain so that I don't have to think two things. You don't have to do that step if you can do it with it all in one. What is negative 5 plus 3? Negative 2. What is negative 2 divided by 2? Negative 5 minus 3 is, and negative 8 divided by 2 is, no. Would that have been faster by factor? 100% faster by factor. The only time I'll have to do it with the quadratic formula is when it says use the quadratic formula.
Oh.
Which might happen on tonight's homework. After that, we're gonna. Before, this is a kind of a 2-day lesson. I'm not done, so don't pack up. I'm gonna do one more problem. But you have 2 assignments. They are both due on Wednesday. The second one's much shorter than the first one. I pretty much separated it into where I thought I would get to today. So I think you can all do page 195. I think you can, the first page 195, you can probably get that all done tonight. It's up to you how you break it up. This is all due on Wednesday. Some of them will be solved by factoring, some of them by taking spurs, some of them quadratic formula, some of them only using the discriminant, so read the directions so that you don't do 100 quadratic formula that you are supposed to. Just make sure you read the directions. The thing that we don't know how to do yet, we might get one in, but the thing that we haven't seen an example of is solving graphically. So that's the thing that we're going to pick up. We might get one example in today. So if you come to one of the, I don't think the top one will have it graphically solved. Let's skip it for now. Unless you get it in the one you want to get it. Cut this one down. Both of these assignments will grade both of them on Wednesday. Tomorrow we'll finish the notes. Okay, so I want to do one by solving graphically. Is everyone with me? Okay, the first thing I'm going to do, even to solve graphically, is I'm going to get 0 on one side. So that x squared plus x, I'm going to write that as x squared plus x minus 6. I'm going to put that in y1 in my calculator. So x squared plus x minus 6 in y1. We're going to find intersection. In y2, I'm going to put 0. If you don't want to do that and you want to use your zeros button, you can. I like 0 because the intersection button's quicker. And I like speed. HCT maybe is my reasoning. I'm not sure, but so now I can graph it, and I'm going to look at where it crosses the x-axis. I'm going to go to second trace 5 and push enter 3 times. It gives me one of the answers being 2. So if I had factored or if I had done the quadratic formula, one of my answers would have been 2. I'm going to go to second trace 5, and I'm going to move over to the other intersection. Get close to the other one. And I'm going to push enter 3 times. And it tells me the other intersection is -3. So that's how you solve in the calculator. Calculator has its limitations. If the answer is imaginary, let me show you really quick what that would look like. You see how this parabola does not cross the x-axis? That's because it has no real solution. So if you were to do the quadratic formula on it, you would get imaginary answers. If it said solve graphically, you just have to say no real solution. If you were on an ACT that didn't tell you how to solve and it had eyes in the answers, you'd have to go do it by hand. So It does have its limitations, but it tells you some pretty good things.